Hello friends, we are still not employed by a FAANG company, so let's not stop lead coding till we get there. So the question we are going to do today is called longest increasing path in a matrix. And if we see some of the companies where I want to get a job who have already asked this question, there are companies like Apple, DoorDash, Google, Facebook, TikTok, Nvidia, Amazon, Uber, Microsoft, Snapchat, ByteDance and bunch of more. So I'm going to pay my utmost attention. I hope you also find this useful. So this is a LeetCode hard problem and also a very well-liked problem, which is a rare combination to find. Basically, we are given an m cross an integer matrix and we need to return the length of the longest increasing path in this given matrix. Now, how do we build this longest increasing path that we need to return the length of? Essentially, we are told that from every single cell, we can move in 4 directions, left, right, up or down. And based on that, we need to calculate that what is going to be the longest increasing path. We are also explicitly told that we don't have to care about diagonally moving or values outside the boundary. So let's try to understand this with an example. Suppose in this case, this is the example that we are given. Now our aim is to find the longest increasing path. Now we know that from any single cell, how to define an increasing path. Let's say that we are currently located at this cell number 4. Now we have the option to go in 4 direction, up, down, left and right. Now from this 4 direction, we only need to go to the direction of the cell that is actually increasing order. So we need to maintain this increasing property. So from this value number 4, what are the places we can go? We can go to 9 and we can go to 8. We cannot go to 6 because this would be a diagonal and we cannot go anywhere outside the boundary. Now in both the cases, we have the option that the values are currently in the increasing order for this 8 and 9, which means both are legitimate scenario. But our aim is to find the longest increasing path. So from 8, do we have any other option to go to that increases in the path? No. From 9, do we have any other option to go to in any next cell that increases? Again, no. So in this case, from 4, the longest increasing path we can make is going to be 2. But is this the longest inside the given entire matrix? The answer is no. We need to find the cell that has the longest increasing path. So if we take one more example, let's take an example for this value number 1. Again, at this location value number 1, we have the option to go into 4 direction. But let's say that for the ease of convenience, we decide to go into the direction of this 1 to 2. Currently, the increasing path length is 1. Again, from this 2, we have one more neighboring cell that is higher than the value, that is this value number 6. So this time the increasing path value will increase by 1. And again from the 6, we can go to one more neighbor that increases in the value, and that is value number 1. And originally we started with this value number 1 and we moved one hop. So basically we will add one more over here. So essentially we can create a path that looks like this, 1, 2, 6 and 9. And this would be the longest increasing path in our matrix, and the length of this matrix is going to be value number 4. That is what we need to return in the answer. And the first approach comes to our mind is the brute force approach, the very basic approach that we can take to solve this problem. Now let's try to understand that what would be the brute force approach in this manner. Well, of course, the answer is quite simple. From every single cell, we start iterating in all 4 directions. And from all 4 directions, we will see that where we can find the increasing path. And the moment we find the increasing path, we keep on adding the value to our answer variable. And we will keep on adding 1 over here. And same way for our increasing path, we will go to its neighbor. And again, we will keep on repeating the same process. So let's try to see the solution I'm proposing in action. Okay. So let's say that for the ease of convenience, we start at value number 1 or this value number 9. Again, from 9, what would be the increasing path we are able to make, and what is the maximum answer we have found so far? These are the 2 variables we are going to keep track of. So 9 does not have any neighbors that are in the increasing order, because 9 is the biggest value amongst all. So in this case, we won't be able to find anything. Let's go to this another 9. Again, same thing will happen. We won't be able to find anything. So these 2 are the values that we took care of. Now we are at value number 4. Since value number 4 we already calculated that there are only two paths we can take, so currently the increasing path maximum we can make is going to be 2. So answer currently we have found so far is value number 2, that this is the maximum path we are able to make. But let's keep on increasing with next subsequent values. So currently the values we took care of is going to be the first row, so I'm just going to mark them as X, that we already took care of this. Now we are at this value number 6. From 6, what are the options we have? We cannot go here because this is not increasing, this is same. We can go here to 9, so this is good. So from 6 we can again create a path of increasing path of size 2, and then that's it. So again our answer will remain same. We also took care of 6. Same goes for this 6. This 6 we have the option to go to value number 9, and we have the option to go to value number 8, but that won't lead to any further results. So again we cannot move anywhere forward. So we also took care of these 5 variables. Now let's move on to value number 8. Again from this value number 8 we do not actually have any path to go to, so we don't even bother updating any of the variables. Now we are at value number 2, and now things will start to get a little bit interesting. So what are the options for the increasing path we have at value number 2? So first increasing path option is over here, so from 2 to 6, that is good. Again from 6, do we have the option to go for the increasing path? And the answer is yes, that is 6 to 9. So in this case from this value number 2, the maximum increasing path we can achieve is going to be value number 3. So we are going to update our result, and so far the longest increasing path we have found so far is going to be value number 3. So again we are going to update our answer as well. Now we are at value number 1. So what are the options we have so far? Can we go to this? No. Can we go to this 6? Yes. So currently we go to this 6. From this 6, what are the options we have? We can either go to 9 or we can either go to 8. So let's just first go to 8. Okay, now we went to the 8. From 8, can we go anywhere else? No. So in this case, for this particular path, the answer we found is 3. But we still have one more option, that from 6 we can still go to this 9. So even if we go from 6 to 9, we don't have anywhere else to go. So once again the answer is going to be 3 as well. Now after taking care of both of these paths, now let's explore more options, and that option is that from this 1 we can go to this value number 2. Okay, from this 2 we still have option to go to value number 6. From this 6 we still have option to go to value number 9. So in this case we created a path that is 1 to 2 to 6 and then to 9. So in this case we created a path with a path length of 4. That is going to be the maximum path we have found so far. So we are again going to update our values. So this is going to be the current increasing path we found for the cell number 1, and the maximum path we have been able to find is also going to be 4. So we are going to update our answer because we need to enter the longest increasing path. And now we still have one more value that we need to go to. So again from this value number 1 we have the option to go to 1 to 8, and then from 8 we won't be able to go anywhere else. So in this case the maximum path we are able to achieve is going to be 2. After completing or after iterating every single value, we found out that the maximum longest increasing path we can create is going to be value number 4. So our brute force approach gave us the appropriate answer that we were looking for. But was it the most optimal answer? Well, the answer you already know, that of course not. And why? Because there are a few things we can actually make changes to. So first thing we can make change to is going to be regarding that for every single cell we were actually doing a lot of repeated computation, and how we were doing that, let me give you a quick example. So again, let's clean this up a bit. Initially when we were traversing our answer, when we reached to this value number 6, we already knew that from this 6 there is only one path we can go, and that is going to yield us the higher result, and that is from 6 to 9. So the longest increasing path or the longest path we can make at value number 6 was going to be 2. Now when we came back to this value number 1 originally, from 1 what we did was we went from 1 to 2, from 2 to 6, and 6 to 9, every single place repeating the computation we have already completed, and that is a bad approach. What if we already knew that at value number 6 the longest we can do is going to be 2? Same way this value number 2, the longest we can make is going to be value number 3. So based on this information, if we are at value number 1 and we need to go back to this value number 2, we can clearly see that from 1 we already know that there is an increasing path that leads to 2, but from 2 we already know that the maximum amount of value it can generate in terms of longest increasing path is going to be of value number 3. So rather than doing all of this computation, we could have actually just done from 1 we reach to 2 and see that we already have the computation result for 2. So we could have done 1 plus 3 and the answer would have been immediately available to us as the value 4. So this is one of the major significant improvement we can make. And what this improvement is, this is actually we are storing the results that we have already calculated. So what we are doing is one of my favorite things and one of the most beautiful things that is available in the computer science, that is we are actually using dynamic programming in this case. But on top of using dynamic programming, we are also doing something more interesting, and that is that we are actually rather than treating this as the matrix or 3 by 3 matrix, we can actually treat this as individual nodes, and this individual nodes would have some way of connection with them. How connection? Because we are trying to find a path. Now for this path we are actually given the definition that if only from this current cell, let's say the value of current cell is A, if there is a path from A to B where B is greater than A, then only we can connect A to B and consider it for our path. So rather than treating this as just 2 by 2 matrix or m cross n matrix, we can actually consider every single cell in this matrix is equal to node and the path that we are trying to connect actually as the vertices. And once we do this, after seeing these two words, immediately in your mind it's gonna click that essentially we are treating this as a graph solution, and we are in the graph we are trying to find the longest increasing path. We already know how to build a path, and that is using the greater than or less than relation between any two cells. So essentially we already have a directed graph, and we already know that there won't be any cycles in this graph, because let's say that how does the cycle occur in a single graph? Let's say we go from 3 to 5 up in the same position 3, then we can see that there is a cycle. But in this case it is not possible to have a cycle. Why? Because the relation of this edge is actually based on the property that 3 is less than 5. That's why there is an edge that exists over here. If 3 was not less than 5, then there won't be any edge over here. So which means from 5 to 3 there is an edge, there is an impossible way to create an edge. So essentially this is also going to be an acyclic graph, and we already know that this is a director acyclic graph, and in the DAG or directed acyclic graph we are trying to find the longest path. Basically, rather than treating it as longest increasing path, we are just trying to find the longest path. So essentially now our life becomes much easier. On top of that, we are already going to use the dynamic programming properties. So we are going to know that how we are going to take care of every single value. So we are not going to repeat the computations that we have already created. Now let's see that what would be the solution look like in action. Okay, so now what we are going to do is we are actually going to create a dynamic programming to m cross n grid, and in this case we are going to use this to store that every single element, how many increasing path we can make, maximum amount of increasing path we can make. So this would be a great help for in terms of memorization. On top of that, for every single node, we are treating it as a graph, and we are going to build the graph upon them. So we are not actually creating a separate graph. We can actually use the same matrix. For the visual representation, I'm going to make some circles and some arrows, but you would be able to imagine that what we are actually trying to do. So first, let's say that we are at value number 9. So we are at a graph node like 9. From 9, do we have any edges extending out? No, because this is the same as 9 and this is less than 9. So there is no edges, which means the longest path we can make at value number 9 is going to be of value number 1. Okay, we are good with this result. Now at this second cell 9, again same thing is going to happen, that we are going to have a single cell that is not able to branch out or connect with anything else. So once again the longest path we are going to make is going to be value number 1. Now we are at this value number 4. What are the options we have? So let me just clean this up a bit, and from this value number 4 we actually have a couple of options. We can either grow from 4 to 9, or we can go from 4 to 8. So let's say if we decide to go from 4 to 9, do we need to calculate that from 9 how many values we can go to? No. Why? Because we already know this result. So from this 4, let's say if we decide to go to 9, we are actually going to create a path like this, that initially we are going to have a node 4, and from 4 we have the option to go to 9, or from this value number 4 we have the option to go to value number 8. So currently we have two options. From this 8 we don't know how many options we have because we haven't calculated, but we already calculated the result for this value number 9, which means if we decide to go from 4 to 9, we are for sure guaranteed to have an increasing path of 2, because from 9 it does not lead anywhere else. So we are good with this so far, which means and from this 4 to 8, let's say if we decide that from 4 we are going to go to 8, what are the options we have? From 8 we cannot go here or here. So again from 8 there are no possible nodes that we can calculate, which means we are again going to be able to create a maximum path of 2. So in this case, rather than doing all of this computation, we can actually store our answer, and we can just put down the value 2 over here, that this is the longest path 4 can take. Now we are at position number 6. From 6, what are the options here? It has, well, 6, as you can clearly see that 6 is not able to go over here. It is only able to go over here, and this we have already calculated from. So that means that from 6 we only have two options, and that is the longest path we can make is of value number 2. Again from this 6 we have two options. We can go to this value number 8, or we can go to this value number 9. In either case, the maximum path we are going to make is going to be of size 2. Reasons you already know. From this 8 we cannot actually go anywhere else, so the longest path we will be able to make is going to be 1. Now from this value number 2 we actually have just one option that where we can go, and that is to go to this value number 6. But from this 6 we already calculated the results, and that is going to be 2. So in this case we can clearly write the answer as 3. Now from this 1 we actually have multiple options to go to. So this I'm going to draw in the answer, and you would be able to understand what I mean. So initially we are located at this value number 1. From this 1 we have the option to go to value number 6. From this 1 we also have the option to go to value number 2, and from this 6 we have the option to go to value number 8, and we also have the option to go to value number 9. From this 2 we have the option to go to value number 6, and then 6 we have the option to go to value number 9, and currently we are located at this position. So these are the possibilities, or these are the options we can have. Let's assess each path. So in this case, if we go from 1 to 6, then from 6 we can either go to 8, or we can either go to 9. In either case, the answer for this portion is going to be value number 3. But in this case, if we decide from 1 to 2, 2 to 6, and 6 to 9, we are going to get the answer to be of value number 4. So in this case, 4 is the maximum answer we can get, but we don't actually have to do all of this computation. Why? Because we are using dynamic programming. That is the most important concept so far. So from this value number 1, the moment we see that this is where we can go, our mind should click that if we take this path, then what we would do is from here if we take this path, then the sum is going to be 3. But from here, if we take this path, then the sum is going to be 4. So obviously we are trying to find the maximum value, so we are going to store the value of 4 rather than storing the value 3, and 4 is here. Now we are again located at this value number 1. From this 1, can we go over here? No. Can we go over here? Yes. So what is the maximum path we can make? We can do one jump like this, and we already know that there is only one single entity path we can choose over here. So maximum value we can get is going to be 2. So this is going to be our dynamic programming graph combination matrix combination solution, and that is why this is treated as a hard problem. But in my opinion, if you already knew these concepts, then it won't be so difficult for you. And after watching this video, I can guarantee that this is definitely not going to be hard for you. So we can clearly see that in the end we only need to return the maximum value that is present inside the dynamic programming graph, and that we can return quite easily, and this is going to be the whole solution. Now this is a very beautiful solution. If we see time and space complexity in this case, essentially the time complexity is going to be big O of 2 times m cross n. So overall we can write the time complexity to be big O of m multiplied by n, which is a very good time complexity. And if we see space complexity, well, this is a little bit more expensive because we are using an additional 2 by 2 or m cross n matrix over here. So this is also going to be big O of m multiplied by n, but this is also reasonably acceptable. This is not very complicated. So in my opinion, this is a very good problem to understand 3 major concepts, and that is graph, dynamic programming, and also matrix. So everyone should do this problem at least once. Now let's go to the coding part that is not so difficult. So basically, first of all, we are going to create a 2D array to store all the directions that we are going to traverse over. We are also going to have some private integers that we are going to use. Now the first idea is to create or to find the longest increasing path. As an input, we are using the matrix that we are given in the input, and we are simply going to iterate over the given matrix. We are also going to create a cache or a dynamic programming m cross n array, and we are simply going to have our answer stored initially as value number 0. Then with using 2 for loops, we are going to iterate our n cross n array, and we are going to check that whether at any single cell position are we finding the maximum longest increasing path or not. And to do that, we are actually going to call another helper method called dfx, where in the dfs as an input we are going to provide matrix, the current ith and jth position, so to identify that which cell we are talking about, and the current array that we or the current dynamic programming matrix that we have created and populated. Now inside our dfs method, we are first of all going to check that for any particular value, are we or have we already checked that particular cell value or not, and we are going to initialize the dynamic programming array as 0. So if the value is not equal to 0, then we need to find the value for that, and we are now going to iterate in all 4 directions from that particular cell. Then we are going to check that we are going out of bounds or not using these 4 conditions. If not, then we are only selecting the path where the adjacent values are going to be in the increasing order, and if that is the case, then we are going to update the value of our current cache with whatever the maximum value we can find for that existing cache, or recursively calling the dfs method again. And in the end, we are going to add one more value to our cache because we found an additional path that exists. And let's say if we don't find any additional path, still the initial value of cache is going to be 0. So if we increase it by 1, it is going to be added by 1. So let's try to run this code. Seems like our solution is working as expected. Let's submit this code, and our code runs pretty efficiently compared to a lot of other solutions. I would be posting this code in our GitHub repository, and that link for our GitHub repository is actually posted in the description, so you would be able to check it out from there. Thank you.